far as you've noticed, I think most of the people kind of faded away and you were getting your questions answered. So I don't foresee us running out of time. There's only a few of you in the room now. So, but maybe that's the way to go, is to say, all right, since I'm going to send one out anyways, maybe ask the other ones. But I'd gladly do the other ones too. So, I mean, we did some good ones today. That last one we just did with before the break, Daniel, with you, the dipole and it had the dipole and the expansion. I forget the number. Oh, it's number 18.
Yeah, I need to redo that one.
Yeah, I mean, I would gladly send a video on that one too. So anyways, with that said, there's just a few of us, so, unmic yourself and ask, or send it to the chat. Let me turn on the chat here, and I'll just send a message, hi, kind of get it started. But, if you wanted to, I'll just look up there every once in a while, try to answer a question, especially if it's a short one. I'll just logistically fall in there. A lot of these are long questions, I'm stuck on number 60. And as you know, that none of these problems in 122 are easy. So who would like to go first? Feel free.
If nobody else has a question, I've actually got, I think might be a simple question on number 45, chapter 23.
Okay, let me get to my other screen here and jump over to 45, you say. Actually, I'm going to rearrange my tabs so things are closer. That'll be easier. All right. Hey. That was weird. I lost that tab. I might have to bring it back. Let's see. Oh yeah, this should have been it. It should have been my drive, and I don't.
I don't have any questions. I was just coming in to say hello, so I'm gonna head out now.
Okay, Jonah. Oh, real quick, what class you from?
Oh, 121 with Doug.
Okay, good. Yeah. So, same as all of these, if you ever have a question during the week, feel free to email me. Nobody in 121 has really asked me anything yet, and it makes sense. I think the understanding I got is you guys really have been focusing more on the logistics of how do you do a remote class.
Right. Yeah, it hasn't been anything too challenging yet in terms of homework.
Right, and just to give you a little heads up, and it probably won't be. The first chapter is like converting units, significant figures, and the next chapter is teaching you the mathematics of vectors, and then finally, in chapter 3, you start doing some kinematics, and even then it's one dimension. And I don't want to understate it, but it is fairly on the easy side compared to what you're going to get. Well, that's
comforting to hear.
And so know this, that this is for you. So if you still don't have any questions next week, that's fine. You don't need to show up. But I know that as the semester goes along and things get harder and harder, you're going to have quite a few questions. And so show up on either Fridays and ask them in a virtual face-to-face setting, or shoot me off an email, and be glad to.
Yeah, I don't think I'll have any shortage of questions once we get into it.
Okay. All right. Great meeting you. Take care.
All right. Nice meeting you as well.
All right. Let's see, Scott. Let me go back here. So I somehow during the break lost my listed homework questions. So I'm going to need to reopen my drive here, and there it is in my recents. That's nice. Okay. And I'm sorry, Scott, I forgot the number. What was it?
45.
45. All right, let me scroll down. Oh, good, 45. Oh, yeah. This is a good one. It's a combination of, and I'm going to start from scratch. I guess I could, I'm going to say I did this in the first session this morning, but probably better just to start from scratch. I think it's more educational for you than me to pull something up that was already done. So let me share with you a little video camera that will, my phone really, that will point downward on a piece of paper. And get this going. Nice. Let me see if my pen works. Ah, good. You can see my pen. One time this morning when I logged in, it had like a 7-second delay. It was weird, but it was a fun exercise in that. Okay. And so maybe I'll just put, wait, we got a delay again. Why do we have a delay? Well, I think I can live with it again. I'm gonna. How
many seconds is the delay?
Yeah, I'm gonna try it here. So I'm gonna do this. I'm gonna start writing. 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000, 6. Looks like about 6 seconds there.
What you could try doing.
You know, last time when I stopped sharing and went back, I'm going to try that. And then I'll try your advice.
What I was going to say you could do is just log out and log back in of your other account.
Yeah. Okay. Let's. I'll just try the share. I know that last time that fixed it.
Love the stash, by the way, Scott.
Thank you. Appreciate it.
Yeah, I was going to say, man, it's solid. I wish I could grow something like that.
I had just a whole thing going on last weekend. I went with the goatee. I like this much better.
Just need
I'm
some
gonna try
dreads.
this one.
Be a pirate.
1, 1,000, 2. Oh, good.
Oh,
good.
perfect.
Yeah, I got rid of the delay. Yeah, it's interesting on the delay. Okay, so all right. So let me get rid of this piece of paper. Put it all over it. Okay, and back to question 45, and I'll begin. And I believe it was Scott who asked this, right?
Yep.
Chapter 23, number 45. I'll just put it at the top in case anybody pops in and wants to see what we're doing, and or maybe on the recorded part of it. But I think my video lectures are a little better because it's just specifically on that question and not all this delay stuff, or like in that case, trying to fix the delay. But let me draw a little picture. So here is what I'll just call the ceiling of whatever building we have. Here is a vertical line going down. Here then is this, how do they describe it? They say charged cork ball. And they say it is 1 gram, and it is swinging over at an angle. The picture says theta. Let me just read it. Yeah, it says in the problem 37 degrees. And then they show a picture of an electric field, and they have what looks like a uniform field with a bunch of lines. I'm just going to draw one of them. But they say the electric field then is equal to, and they got 3 in the x direction, 5 in the y direction, and it's times 1,000 and the appropriate units, newtons per Coulomb. Okay. And so the question goes on, I believe it's a 2-part. Yeah, part A, find the charge on the ball, and B, the tension. Okay, so the ball is hanging there, it's stationary, and hopefully one of the first things going on in your mind is this sounds like a Physics 121 question because of static equilibrium. Going back to Physics 121, we know if you add up all the forces, that has to equal to MA. And if something is stationary, then that A is a 0. All right. So we solved these ones back in Physics 21 in what we called free body diagrams. And the only thing added to this from last semester, or 2 semesters, whenever you took 121, is that as I draw all the forces, the ones we were used to in Physics 121 were gravity and the tension. So I'll kind of label those 2 forces. The new one, which is what this semester is about, is the electrical force. And I'll say then F equals the charge times the electric field. And if you didn't quite get this out of the reading, hopefully you'll see that this is saying that a positive charge would be in the same direction as the electric field, but a negative charge would be in the opposite, because you would have a negative in front of this, so the direction of the force. So I need to come back over here. They told me the field is up at an angle, and the force would be that same direction if it's a positive, but it would be down this way if it is a negative. And so let me come back over here and see what they say. They don't say. However, maybe they kind of expect me to realize it's got to be positive because gravity's pulling it down, and if the field pulled it down, it wouldn't be possible for it to be stationary. So maybe that's just as well. So we know it's got to come out to be a positive charge, but maybe we'll just write it as a Q and let the math play out. And then if we got a negative Q, we will be very concerned. But it's got to be a positive one. So with that in mind, I'm going to put this. I'm going to say here is a third force. That's the new piece. And so there's my free body diagram. And to put some angles on my free body diagram, let me come over here and say, okay, that is the same as the 37 degrees. Maybe you got to come back up here in my picture to see it. If that's swinging out and you draw a vertical line, these are alternate interior angles from our geometry. So we know that alternate interior angles are equal. Okay, so that's 37. And we might be tempted to find the angle here, but thinking ahead a little bit, we know that we're going to have to say that the forces in the x direction add up to 0 and the y direction add up to 0. So if we use what's new to us and put in Q for the charge times the electric field, which is 3I hat plus 5J hat times 1,000 newtons per Coulomb. That would mean right here, we would have a 3, maybe I'll write it as 3,000, 3 times 1,000 Q in the I hat direction, so the x direction. And the other one here would be a 5,000 times
Sorry, is
Q.
that 10 to the 5th or 10 to the 3rd?
Yeah, that's
that number, yeah.
Yeah, 3.
Okay.
Let me scribble it out. 3. See, that looks a little better. And let me also just double check.
Why is it 10 to the 3rd? Shouldn't it be 10 to the 5th?
It is a 5. Oh. Let me zoom mine in.
Good catch, Danny. I was just going to go along with it.
That's a 5. So that means when I did it this morning, I used a 3 this morning.
Ooh.
I messed somebody up. Bummer, I should have zoomed in better. Okay. Okay, so let me fix this. And so 5 zeros is 100,000. So this is 300,000 I hat and 500,000 J hat. That's getting big enough. I probably should have left it as times 10 to the 5. Okay, but I wanted to do that because kind of first in this, because the other stuff you've seen in 121, and hopefully when I start going through it, the rust spots will start coming off if you haven't seen it in a while. But the new stuff is that this then is this third force. And so that's what is new for this semester. Continuing on, and maybe I'll kind of leave that free body diagram kind of close there. When I do these static ones, I like to kind of make 2 columns on my page and say, okay, this is the X and this is the Y. And so if I add up the forces in the X direction, that's supposed to be 0. And the same thing needs to happen in the Y direction. That needs to come out to be 0 too. So coming back and looking at my forces, these are the 3. And what I'll call the old school ones are right here. These are the ones that you've seen before already in 121 class. And then this is the new one. And so in the X direction, it looks like I don't even have to think about gravity. Its weight. These are the ones in the X direction. So I'll put 0 equals, and the X component of this one would be in the negative direction. Its magnitude would be its tension, and the X component would be opposite of the 37 degrees. So
How come you chose sine?
I'm going to answer that in just a second, Daniel. I'm going to, just out of curiosity, you guys could tell me, do you think I should use paper with lines or without them? Does that make it worse? 0 equals negative tension sine 37 degrees.
I can see a little bit better on the paper without lines, but I can see them both.
Mhm.
So it's
Yeah.
more of a preference thing, whatever you would prefer.
Yeah, I'm fine with either.
Okay. Well, for right now, I'll just go with lines since I have it out. But I might switch over. I think that was a little better. But when I don't have lines, I get pretty sloppy. So that could end up being worse later on.
I do the same thing. I have grid.
Yeah. Oh, so Daniel, you had a great question. How do I know it's sine? All right. So let's let me pull this page out of the way. Let me just go back to your trig class. And if we're looking at some angle theta, and we call this leg A and this leg B and this leg C, the sine of an angle is defined as the opposite.
Okay. Opposite over hypotenuse. Got it.
Right. So coming back to this picture here, I have this angle and I want to know this component. So it's the opposite.
Okay.
And so, yeah, you should, and a little hint for you and everybody else is when you start working with sines and cosines, you should use the phrase opposite and adjacent, not X and Y, because you never really know what angle you're looking at. The opposite is always correct for the sine, and the adjacent is always correct for the cosine, whereas that's not always the X or the Y axis. Okay. All right, so good. I'll say it again and move on. So I want the opposite of the 37 degrees, and opposite is my trig function called sine. So there's my sine. And then in the plus direction, this force, this is the new one, the electrical force, does have an X component. And this is why I was saying we're probably better off not to figure out the angle here, because this piece of it right here, this alone is the x component, whereas this is the y component. So I can just put down I'm going to run out of space, 100,000 Q. And that would be the x component of that one. Now, before I go over to the y one, let me just do a little bit of math and move this to the other side. So t times the sine of 37 degrees equals this 30,000 times q. And so I'll call that my first equation. And again, notice it's got the two unknowns that they're asking in part A and part B. Part A is saying, what's the tension? Or would that be? Part A says, what's the charge? Yeah. So part A says, what's the charge? And part B says, what's the tension? So this is, of course, two unknowns. So I need another equation, and that's where the y direction is going to come into. So now I'll do the same thing. And so I'll say 0 equals, maybe I just better go down to this line here. 0 equals, and now I need to add up all the vertical ones. And so I will go tension. And the vertical one would be adjacent to the 37. And so the trig function that gives me adjacence is the cosine of 37. I'll even put a little positive there. I don't need to mathematically, but that does help me keep reminding myself that when I'm looking for a component, I'll go magnitude, component, direction, and this one's up, so it's positive. And of course, this other one, this new one, the electrical force, is also upward, and that's what that was right there. And it's in the positive direction, so that's the 500,000. Oh, I think I left off a Q. My apologies. When I that Q times the 500,000. And then this one here is all down. And I'll just write it, if I can just squeeze it in and move over my video camera or move over the paper. That'll just be an mg. And maybe if I solve a little bit, I'll move the mg to the other side, and then I will have a t, I will have cosine of 37, I will then have 500,000 q. And keep in mind, way back somewhere in the drawing here, hard to see now that I've written other things, but it was in the problem, it said that the mass was 1 gram. So this would be 0.001 kilogram times 9.8 meters per second squared. And so 3 decimal places would go 0.0098 newtons. And then tension, cosine 37 plus 500,000 Q. So I'll keep going, but at this point I just wanted to pause and say, okay, if you notice what I did is really, I've done very little from this semester, right? From this semester, all I did was say they gave me the electric field, and from electric field I can get force. So the charge you put there times the electric field gives you the force, and then I just put it as one of the 3 forces, did a free body diagram. That made me go back to physics 122, and that has X and Y components. Now I'm ready to go back to algebra, because now I have 2 equations and 2 unknowns. I suppose to make it look a little nicer, I might actually get out a calculator and say, what is the sine of 37? And it looks like that is a 0.602 t equals 300,000 q. And then on this one here, I might say, what is the cosine of 37 in a decimal form? And it looks like it is 0.799. So write this as 0.0098 equals 0.799t plus 500,000 Q. And so now I have two equations and two unknowns. And that's what I mean by going back to algebra 2 here. So I'll go ahead and maybe solve this one up here for t. So t, the tension equals, and this would be 300, 1,230,000, divided by 0.602. And then this would be 498, and with 3 significant figures, I'll just leave it there, times Q. All right, then use that back in here. So this is 0.0098 equals 0.799, and there's where T comes into play. So I'm going to substitute it in. 498,000 Q, and then plus another 500,000 Q. And grab my calculator here. So up a little higher so you guys can see it. There we go. So this right here is, well, I already got the 498,000, so I'll just hit times 0.799. That'll be that Q. And I'll just add to it 500,000. And it looks like that is 898,000 Qs. And so finally I can get to my Q. So 0.0098, then divided by my last answer. And I get a 1 point, and I'll just go 0.9.
848, right?
Say that again?
That's 848,000, right? Or is it 98,000?
Oh, 98. Did I say 48?
Okay. I don't know.
Oh, it looks crappy. I see. That's a 9.
Okay.
Yeah. Yeah. Maybe you can see it on the calculator screen there. It's 8,9.
Okay, yeah. I see that.
Yeah. And this was times 10 to the negative 8 for the charge, which I suppose we could stop there. I always like to write it in a prefix. So if I made this a little bigger, it would be 10.9. And that would make this 10 to the minus 9. That's a nano. And so there's the amount of charge, if you will. And this, I think maybe I'll just scan the solutions I gave you guys here. Let's see, number 45. Let's just
So
sure
my calculator already just rounded it to 1.1 instead of 1.9. Is that, oh, or like that? So wait, hold on. That's, I don't know if you can see it, but that's what my calculator rounded it to. I know it's backwards.
Oh, yeah. Can you, it only did it because the way your calculator is set up, it can't show you that many decimal places. If you put it in scientific notation, I think you would see this though.
Okay.
Press mode on your calculator. There should be a SCI mode, and it'll automatically put everything into scientific notation.
Yeah, that
Okay.
it was in regular.
Yeah, so either mode's fine, except with something like this, when you have so many zeros, your calculator is going to cheat you a little bit and round it.
So maybe that's what happened to me on the other problems is I just didn't have it in scientific mode and it just rounded it off than normal.
Yeah.
I have a simple question. I actually didn't know where the solutions were, so I was doing all the homework problems blindly without being able to double check.
Oh, well, you're stronger for it.
Thank you. I appreciate it. Definitely felt lost though.
Okay. Do you want me to find the link and put it in the chat?
It's okay. I can just email you after. I just didn't know that was actually a thing. I just wanted to see if that was still accessible or not. So.
Yeah, sometimes I'm looking at the page on my other calculator and I do have you zoomed in. Oh, that's why I do want to log in so I can see you guys in the chat. I love the shirt. All right. Is that my shirt or somebody else?
No, your shirt. Your shirt, yeah. It's always those nice short sleeve button ups. I'm all about them.
Yeah. Okay. But let me stick this in the chat, but also point out that you might not have noticed it, but it was in my email that gave you the instructions for this week. The email that had watch these videos.
Mm-hmm.
Is there any chance you could post those on Canvas somewhere?
I could. I don't know how yet, but yeah, I could.
Okay.
Yeah, maybe that would be. It might be better if I just started using. Canvas is new to me, and so. But I see how it could be really to your advantage to have things all in the same place for a class.
Yeah. Right now I'm like, and it's no problem, but like it's a few extra steps just going to my email, finding the email, and then opening the solutions.
Well, I'll tell you, and I'm sure there's an answer to this. I just don't know it. Here's been my dilemma with Canvas, and it's the way our school is run. I have you guys in class, and there's about I'll say 120 of you, but then the school breaks you into groups of 20 for the labs.
Weird.
And then since you could take it at 2 times, they split that. So when I go to do something on Canvas, I have to do it 12 times.
Oh, I see. Okay. Never mind then.
Yeah, so
that's
ridiculous. A little bit of a pain. Yeah. So that's why I've avoided it. But I'm sure if I ask somebody who's familiar with Canvas, there's probably a way to link all those 12s together and merge them. And so I only have to make the changes one time. So let me figure that out, and then it would be really easy for me.
Okay.
Thank you for putting that in there. I must have overseen that in the email this week too. So.
Yeah, that's fine. That's what we're going at. Oh, now I think I was doing this for Scott, and just out of my own curiosity, although I know you could finish it, I feel like I should finish it here.
Actually, it's okay. I know how to finish it from here, and it's my question. I guess I tried doing this on my own in a similar way that you did it here, and I got an answer queue that just did not make any. It was right. So then I tried following the solutions in the book, and well, let's just say it didn't make too much sense when I got to a certain point. I could actually share my screen with you if you want to see the exact point I'm talking about. I have the word "why" with a question mark pointing at exactly what I'm.
Okay. Yeah. Now I think for you to share, I got to stop sharing.
Mm-hmm.
And I have to also open up the Zoom meeting on my iPad.
If I did this right, I set it up so students can share, but only when I wasn't sharing, or something like that.
If that doesn't work too, you can make him a co-host too.
Only the host can share this meeting. Yeah, I won't let me share.
So if you right-click on his video icon for his iPad, it should say co-host, and that will allow him to share. Sorry.
Oh, okay. Make co-host. I see.
I go mad with power.
Yeah. I think
So I just finished out the calculation.
do you want me
And
to
I
do
got
your, wait, hang on, do I want to do your iPad or your screen here? Your iPad.
iPad.
Yeah, okay, I was doing the wrong one. You try that again. Make co-host, okay. Yes.
so while
Excellent.
you guys were
Yeah,
trying to do that, I just typed in the calculation, the 498,000
yeah.
times 10.9, and I got 5.4282 e to the sixth.
Wait. You didn't do nanu. I didn't hear you use the word nanu there.
The NC, the 10.6.
Yeah, okay,
Yeah, but
so
you actually have to type in like 10
But-
point whatever times 10 to the negative ninth.
yeah,
Oh, okay.
That's what the nano Coulomb is.
yeah,
Otherwise, you'll get an answer that is times 10 to the ninth too large.
yeah, which is a billion. And that's exactly what you said. Your answer you have is a billion times too big.
Okay, so I need to do the 498,000 times 1.9 to the negative ninth or negative eighth.
1.09 times 10 to the negative eighth.
Yeah,
Okay.
And if you're going to use 10.9, it needs to be times 10 to the negative ninth.
right.
Okay.
But this here is what I'm talking about. So they have
Okay.
this, and I'm following up until this point right here. This, I don't know where this comes from.
Oh, okay. It's the line before. I might try something here that's kind of interesting and fun. I'm gonna grab what you have on my screen and put it on my clipboard. Let's see if that works.
It's pretty smart.
And then open my whiteboard and
Want me to stop sharing?
Not yet. I did something wrong. Hang on. Let me go back to your screen. Okay, I wonder if it can.
So it still rounds off for me. I get 5.4282 e to the negative 4, and on the solution it's 5.442 times 10 to the negative third. So
Okay, let me hang on, Daniel.
yeah,
I'm going to come back to your question, but I'm going to come back here. Okay, so if I go to share, it says this will stop Scott from sharing. Okay,
That's fine.
So I'll go yes, and then let me go to my whiteboard and share that. Okay, let me go to my other screen. Is that what you guys are seeing? Are you seeing my whiteboard?
Yeah.
Oh, good.
Yeah, we can see your whiteboard with the picture cut out too.
Nice. Okay. It looks like I just put it over some stuff we did earlier. But this is why I bought this touch screen pad here. All right. So I can do this. But you, believe it or not, from this line above down to that line, all they've really done, and you'll hopefully see it right here. You see this? That is weird.
Yeah, I have no idea. I mean, I did this for a long time, and I went through some strange things trying to get cotangent. And
Whoa. Now that I look closely at it, I think they meant. Okay, let me just kind of draw over here. This is the ball. There's got to be something wrong in the writing. I mean, this cotangent, if we just dropped it, would be.
And they combine. It looked like what they did is they combined the two force equations there. Could it have been when you isolate Q in both equations and then try to combine them that you got somehow cosine over sine at some point, and then that would make sense? Like that's the only way I can understand why a cotangent would even be in this equation.
Yeah, so maybe if I shift this up, I mean, that top line I would have expected to be something like this, a Q times, and this is where I think maybe the notation's off a little bit. There should be like an E, not a sub X, but just an E. And then something like either a cosine or a sine, depending on what angle they're talking about. And then another E with a sine. And then when you factor out, as he was saying,
I have these solutions pulled up if you want to.
Maybe I better go back to see the solutions here. What in the world?
That's what I'm glad I'm not the only one.
that is I would not have gone that approach.
Neither would I. And honestly, I was kind of shocked that they did. Or whoever wrote these solutions. I was doing it similarly to the way that you did, and I was expecting an answer, a solution that was along those lines, but
combining these two equations, we get
I figured out the calculation part. It was just not matching up with some numbers.
Oh, okay, good. Let me shoot. Let's see, and they eliminated T from the equation. They got an M. Well, I'm gonna just for the fun of it, I guess, go back to where's my sharing here, and go back to my camera, and let's just see if I get that same equation. I think I see what they did. It's just a different set of algebra, but I think a harder algebra, not exactly a approach I would have done, but it's always a good exercise to kind of see, what's going on, because it looks like they've got these two equations. The first one was the Q e to the x minus a t sine theta. And the second one is a Q e y plus t cosine theta minus mg equals 0. Okay, so what if I did this? What if I took, let's see, this one equals 0. What if I put this to this side and said t sine theta equals QEX, okay? And on this equation, I'll leave the t and the cosine theta over on the left. And on the right, I'll do an mg minus aq ey. Then, if I combine them this way, so I divide both equations. So I put t sine theta there, and over here I put qex. Because when you divide these two, the t's cancel off, and you get your cosine over your sine, which is your cotangent of theta. And then you've got your mg minus a qey over qex. Then, when you move this over to here, qex cotangent theta equals mg minus qey. And we're trying to solve for q, if I'm not mistaken, right?
Yeah.
Okay, so then bringing this over and factoring out a q.
I see it now.
You see it? Okay.
Yeah.
Yeah, it's coming. Cotangent theta minus ey equals mg. And then finally, q equals, you got the mg over ex cotangent theta minus ey. Yeah. Okay, so that's the approach they had. Like I said, I hope I didn't waste other people's time here, but it is always good when you are working on a problem, especially when you see a solution. You want to convince yourself, hey, how did they do it? And, and so in this case, I would say that I wouldn't do it this way. I like the way we did it, and I would continue to do problems that way, but this is the way they did it. So I did a substitution. They did a quotient of two equations. So
okay.
Yeah, I don't know. I don't know why, but the quotient of two equations did not cross my mind at all. I was thinking about subtracting them, and I was trying to subtract and add and multiply by -1, these weird, strange, I don't know, anyway, it didn't work, obviously. That makes sense. Thank you.
And all of those are valid. So, there's a lot of ways to solve for two equations, two unknowns.
I have a question.
Yeah.
On number 29, I just, on the integration part in part A, I don't know how they got I don't know how to do the integration exactly. Is it okay if you just show me the integration part? That's it.
Sure. Chapter 23.
Yeah, 23.
29.
Yeah.
Okay, let me go to my other screen here so I can see the question 29. Let me move my tab a little bit closer so I can get a little more organized. 29. Oh, okay. Yes. Okay.
This was a fun one.
Actually, okay. Let me do two things here. The easy way and the hard way. How's that? Okay. Let me come back to the solutions. Go down to number 29 and jump right to that integral, because this is important thing I want to clarify for you guys. So as I'm looking at the solution, the second to last step says this. It says the electric field then is equal to, let's see if I can find it, 2 times Coulomb's constant times the lambda, the charge density, times y. Then this integral from 0 to L over 2 dx over x squared plus y squared to the 3/2 power. Okay. Now, I'm going to show you the easy way first, okay? but then I'll show you the hard way. Because I think this is your Math 160 class. You've learned some fancy techniques. The first thing you learned was just how to, let me grab this paper here. You integrated just what we call power functions. You had like x to the n dx. So power functions were pretty easy, I think. Who asked this question? I forget. But,
I did.
okay. So that's an easy integral. Little harder integrals are something that look like this, maybe an x, and then you have like an a squared plus an x squared to the 3/2 dx. This one here is a u sub. If you call u equal to a squared plus x squared, then the du becomes 2x dx. And so anytime you ever see the derivative of something else in your integral, it's perfectly set up for a u sub. And I think I explained that a little deeper in one of the video lectures I sent out, one of those first 3. Now, the ones that get a little harder is the ones we're looking at for this problem. See, this problem looks kind of like this problem, but it doesn't have the derivative in it. But it's got something that looks like Pythagoreans Theorem. And so to remind you from your math class, if you ever see something that looks like this, think trig sub. Yeah, and this one's just screaming at me, do a trig sub, do a trig sub. But here's the short answer I want to give you. When it comes to a test, anything harder than a u sub, like a trig sub, or another tough one is, what do they call it?
Parts?
Not parts, no. That's not too bad. Common factors. Common factors, another hard one. I will not give you any of the integrals that are any harder than a u sub on the test.
Okay, yeah, that's good.
Or if I do, I will then give you it directly. And that's how I'm going to do this problem, at least the first way, the easy way. What I would do is just look this up.
Okay.
So what I mean by that, and there's a lot of ways to look it up, but I'm going to go to the share here, and I'm going to go to my computer. I think I still have the textbook open. Yeah, let me share one of the textbooks. And somebody else was asking about this in an earlier episode. And this, what I'm sharing with you now is, and maybe you could see it over here, right there, Appendix B, at the end of the survey textbook. And Appendix B, keep that in the back of your mind. It is a great reference place. In fact, I'll just go up a couple of pages. Let me go page up, page up, page up. There's their integration by parts. Here's the meaning of an integral. A little bit higher, here's a derivative and some tables of derivative. Going a little higher, here's some of our trig identities. And I think you're getting the point, so I won't go any further. But Appendix B starts off with some simple math and goes all the way up to calculus and gives you a review, kind of helps you out. And the big piece right here is it gives you all these wonderful integrals.
Okay.
And the integral you're looking at is, oh, didn't want to do that. The integral you are looking at and I can copy and paste it, but I think it'll just highlight so you can see it on the screen. Ooh, is that one, right?
Yeah.
All right. So if I,
Our homework is out of the survey textbook, right? And reading.
yeah, I would say right now we're kind of in a transition zone. The survey textbook, it's kind of interesting. The survey textbook, I think, is a little better textbook than the OpenStax, but it was really pricey. It was around $250 or something, and the OpenStax is free. So it wasn't really justified to use it. But then they came out with these low-cost PDF ones that allowed us as a department to buy it and then share it with our students. So now it's free in the PDF format. So we started to change because, like I said, I think the survey is a little better book, but nothing really to brag about. I think the questions, the homework problems are quite a bit better, but the actual descriptions are about on par with one another. But
Okay.
it really didn't justify having the students spend $250 for a textbook.
Makes sense.
And then when they came out with the licensing of the PDF, I was like, oh, well, now wait a minute. I can still give it to the students for free and have a little better book. So I'm kind of in a holding pattern. We were starting to phase it out, and so
Makes sense.
yeah. So that's why I'm assigning the problems from survey. I think the problems from survey are much better. But I think the actual learning of the material is about equal on par. So if you read the OpenStax it would be second volume, chapter 5, you'll see it's nearly identical to the survey book, chapter 23.
Okay. Yeah, I was confused on like what to read, but that makes more sense.
Yeah,
Awesome.
I was kind of going, a little history here. I was kind of phasing in my because I said of the large cost. And then I paused because of the free PDF one. And then last semester was the first time that I shared this whole sequence, or it was team taught. I don't know how you want to phrase it, but in the past, I've always done the whole sequence. And now Professor Folsom is doing the 121. And that'll be our pattern going forward, because there are just so many more students now that I couldn't teach it all myself. But that being said, then when he started teaching it last semester, he was already into the OpenStax one. So I said, well, just go. We're kind of phasing that one out. So you had him last semester, and I'm sure he used the 121, the OpenStax, and not even mentioning the. No, I think he did assign the homework out of the 120, out of the survey.
Yeah, homework came from the survey.
Yeah, he just had that PDF from the survey, but then the rest of the stuff he'd referenced to like OpenStax, but most of the stuff was available online too. So.
Yeah, so you guys bring up kind of a good question for me, how I should reference it. I don't want to confuse you going from one book to another. But I do think the problems are a lot better in the survey and will serve you better.
Yeah, I like the survey problems. They're really hard, but they're depth.
Yeah. Some of them are really hard. Yeah. Okay. So getting kind of back to this question, I think I showed you the easy way, and I'll say it again. Here's the easy way. Here's what the author and me expected for you to do in this problem: to not actually go and do a trig sub integration, but just to turn to Appendix B, or just to go to Google, or what's that great math one?
Wolfram Alpha.
Yeah, we're from Alpha, and just look up the tough integral. So
Okay.
that's what I mean by the easy answer.
All
In
right.
fact, I'll even ask you, do you want me to do the hard answer? Do you want me to do a trig sub? Scott's shaking his head yes.
Well,
Hunter's
I
saying
just want
no.
to see if I did this correctly. I'm trying to follow my work. So, I mean, I'm not going to ask to do it all over again. I can show you my screen and you can point things out like, hey, look, you're bad at math, Scott. Or,
Ah!
good job, Scott. One of those two. But I've already asked a question, so I'm okay if we move on to something else.
Okay, let me, if you'll be okay, yeah, Scott, I'll move on, and there's time here. I'll do a trig sub. That might be a better efficient use of our time.
Okay, sure. All right, thank you.
All right, you're welcome. All right, let's see. Anybody else?
Yeah, could we take a look at 47?
47. Is this Anthony? Okay. Let me jump back here to the questions. 47 says we have 4 identical charges of 10 microcoulombs. They're located in the corner of a rectangle as shown in the picture. Okay. The dimensions are 60 by 15 in units of centimeters. Calculate the magnitude and the direction of the total electrical force exerted on the charge at the lower left corner. Oh, great question. Okay, so with that in mind, let me change my sharing back to my phone so we can see my desk. And also, I need to probably grab some more paper, and maybe this time, just to be a little change, I'm going to go to a no-lined paper. I wonder what the autofocus will do. I'm going to put the pen down there. No lines on it. Okay, so let me just write up here in case anybody does want to see the video. Or chapter 23, number 47. And let me just put the rectangle on here. So we've got these 4 charges. Okay. And let me make sure you guys got this concept. It's worth repeating. But the big concept of this chapter is that the individual electric fields, when added together, will give you then the total electric field. Okay, and so if we knew, for example, in this problem, the electric field from point objects, which we do, we can add a bunch of points to get this rectangle. Or as you saw in some of the harder ones, like adding a bunch of points to give you a ring. And then we have the electric field from a ring. And that's nice because then we could say if you add up the electric field from a ring, you would get a disk. And so you start with the things we know, the smaller things, a ring, a bunch of rings give you a disk. And I think one of the hardest homework problems on here, and I think it's around number 26 or 28, is saying take a bunch of disks and add them together to give you a cylinder. And that's part B of the problem. Part A of the problem is here, take a bunch of rings and get a hollow cylinder. All right. So I'm going to do the same thing in this problem, that I'm going to add up a bunch of points to get the total field. Of course, now this problem goes one step further, and that's what I wanted you to see in the diagram, that it doesn't say just find the electric field, it says find the force. And that's kind of the easy step. I'll put the formula here again, but to get the force, you just take the charge that you have, placing it in the field that's created by those other charges. Now, I'm going to continue with this little diagram and go to, once you know force, you can get acceleration. Once you know acceleration, you can get velocity. Once you get velocity, you can get position. And so all of this stuff we were doing in 121. And what we are trying to communicate with you in this first week right here, I'll call this chapter 23, is that the force can be electrical, which gives your objects accelerations, velocities, and position. And so I'll just cover this up. We're not going to be doing anything for this problem, but I thought maybe a bigger diagram might be helpful for you to see. But this is what I want to do. I want to know, do I know the electric field from a point? Yes, that's Coulomb's law. And so with that in mind, I can add up and get the electric field from those three other points. And then I can then put the fourth charge in the presence of the field that's created by those other three. Okay. And by the way, that's a good point to emphasize. When I go to say add up all the points, what I mean is I'm going to add up 3 because the question is to find the fourth. Like I better come back here and read which one do they want me to find the fourth one on. Calculate the magnitude and the direction of the total electrical force exerted on the charge in the lower left-hand corner. So that one. So that means what I need to do is I need to find the electric field at this point being created from these other 3. And then this is going to be the charge that I put in the presence of the other 3. Okay, so these 3 are going to be pushing on that one. And as you probably remember from 121, you couldn't have something push on itself. That's an internal forces, right? Internal forces, always add to 0. There's always Newton's third law, equal and opposite. So we never worry about the force on itself. So we never worry about the electric field from itself. So my first part of this is, what is the electric field from these 3? Okay, so with that in mind, why don't I just kind of redraw my rectangle? And I'll draw it with a little X there in the lower left-hand corner, saying, look, I'm going to draw it as if, no charge was there for a moment. And then just ask what electric field would be in this lower left-hand corner from these other 3. And maybe now it's time to put in some dimensions. They said this was 60 centimeters, so I'm going to write it as 0.6 meters. They said the width was 15 centimeters, so I'm going to write it as 0.05 meters. They said that these are 4 identical charges, and so Q is 10 microcoulombs. And I'll start conceptually and say, look, this one here would make an electric field pointing away from it. I'll call that electric field number 1. Because we learned, or if you didn't, let me tell you now, the electric field from a positive is away. And then this one would be, I'll call it number 2. And then number 3 would be away, so it'd be kind of down a diagonal, something like that. So these are my 3 electric fields. And so coming back up to here, I need to add those 3 together. And of course, as you hopefully remember, but I'll jog your memory back to 121, when you add vectors, you have to put x's with x's and y's with y's. So it's kind of helpful to maybe make 2 columns, x and y, and say, okay, let's find the electric field total in the x direction first. And so if I look at electric field number 1, it doesn't have anything in the x direction. I'll skip over it. Number 2, all of it is in the x direction, but the negative x direction. So I'll just put negative and whatever the strength is of number 2 is. Now, number 3 is probably the harder one because there is some kind of angle. I'll just call that theta here in my drawing. So it would be the magnitude of number 3, and then adjacent to the angle theta and in the negative direction. So that is my electric field in the x direction. And maybe before I calculate it, we could maybe set up what would be the total electric field in the y direction. I'll bring my picture back in a little bit. But coming back to this picture, you'll see E1 is all in the y direction, and it's all down. E2, electric field number 2, is only horizontal, so I won't put anything over here in the y direction. And again, that hard one is the number 3, because number 3 has both a horizontal and a vertical component. So this would be electric field number 3. And we would want sine of the angle.
That's all negative, right?
And thank you. And that'd be -2. Right. Okay. So with that in mind, let's see. I think I bumped my camera. I'm going to twist it a little bit. Move my paper to a better workspace. Okay. So coming back over to here, let's look. I got the negative for number 2. Number 2 is coming from this charge. And so this would be Coulomb's constants times the amount of charge. I'll just call it Q for the moment. That's that 10 microcoulombs. And the distance away is the 0.6 meters, and I'll square that. Now, here's the harder one. The electric field, or in this case, the X component of the electric field, would be Coulomb's constants times Q. And I guess I have a little bit of work to do here for myself.
Yeah,
Why don't I do this?
Distance.
Yeah, so this is Pythagoreans Theorem. So 0.6 squared plus 0.15 squared would equal the hypotenuse squared. If I grab a calculator, 0.6 squared, 0.15 squared, I get a square of the hypotenuse of 0.3825. Which means also, if I take the square root, the hypotenuse has a length of 0.618. Okay, so now back over here to the X component. So the finishing this equation, this would be the distance squared. I guess I'll, for clarity, write it as 0.618 squared, but we know what that one is back here. We actually did the square first before we square rooted it. So it's maybe clearer to you. I am putting in the equation for a point, the distance squared. And also, hopefully, to make it clear for you, cosine of the angle. So let's come back into our diagram. First, I'll start with some geometry. If we call that angle theta, then these are vertical angles, and vertical angles are equal in geometry. So that's, and cosine would mean adjacent over the hypotenuse. So the adjacent is 0.6, and the hypotenuse is 0.618.
And that's times 6 times over 0.618. Okay.
Yeah, that would be cosine of that angle. It would be the adjacent, that's the 0.6, over the hypotenuse. And that whole quantity is this, the cosine, and I can divide it. So I can grab my calculator here and actually get a number here. I guess the first thing I will put in right here is Coulomb's constant, 9 times 10 to the 9th. I'll pass on the negative for just a second. Both of them are negative. I'll just treat them as positive and put a negative at the end. That'll be okay. So 9 times 10 to the 9th times, and then the charge, I think I remember 10 good microcoulomb, so 10 minus 6, divided by 0.6 squared. That's that first term. Plus, let me do this term. So here we have Coulomb's constant again. We also have the 10 micro. And for that matter, we even have a 0.6. That would be divided by, and if it'll be okay with you, I'll just make that a cube down here, 0.618 cube. And hit enter. So if I entered that right, I got 478. Maybe I'll round it to a 9. 479,000. Let me put the negative. And newtons per coulomb would be the electric field in the x direction. Okay, so then over here, when we do the y direction, it's kind of the same logic. Here's a negative. Coming back to the little picture here, this is the electric field coming from this one. It would be Coulomb's constant, Coulomb's constant times Q. And the distance this one away is the 0.15 squared.
Okay, yeah. And then that second term is the same as before, right?
Are very close. Yeah, it's Coulomb's constant, charged, and the distance away, 618 squared, and then there's a sign. Yeah, I think that's what you're saying. The only difference is sign. So sign would be the 0.15.
Over, yeah, 0.6. Okay.
Mhm.
On the first part of that equation, what's after the Coulomb's constant? That darker part?
That's,
Yeah, that.
that's a scribble. Sorry, it's just
Okay.
Coulomb's constant. I meant to put a little small e for Coulomb's constant, and I put a q, getting ready for that big Q. Just a mental mistake. Yeah. All right. So then, if I kind of do the same thing, and I'll even, if you'll let me cheat a little bit with my calculator, let's just hit the re-enter and just edit this last one we did. It's pretty close to the same. So there's Coulomb's constant, there's the charge, then we divide by, and instead of 0.6 squared, it's 0.15 squared. 1, and I'm going to have to put insert mode 5. Okay, so there's the first term, just because I'm too lazy to type it all again. 9 times 10 to 9, there's the charge, and then again right here, instead of the 0.6, it's 0.1, and then insert 5. And then still divided by that whole thing cubed. So if I hit enter there, I get 1, 2, 3, 1, 2, 3. Oh, quite a bit bigger. 4,057,000 newtons per coulomb.
That makes sense because the 0.15 is smaller than 0.6, right?
Yeah, exactly. And not just that. That's the main reason, but also this angle's a little different, and that means the vertical component for this one's a little smaller. So it kinda takes away. But the biggest reason, as you said, is just how much bigger E1 is compared to E2, because how much closer that charge is than that one farther away. Mm-hmm. So yeah, so I do expect a number bigger. I should put a negative, by the way.
Yeah.
So finally, I can finish the problem because now I did the hard stuff. The easy stuff is this last step right here. Just take the electric field and multiply by the charge you're going to put there. So to finish this problem up, I would do the following. The force is, and then I guess I'd write it out in this form. I'd say the charge I'm going to put there is 10 microcoulombs, good, times the field. And the field is this negative 479,000 newtons per coulomb in the x direction, and a negative 4,057,000 newtons per coulomb in the y direction. And so I get a total answer in components, and I guess we can look at the answer if they want them in components or in magnitude. But going and putting in the 479,123,000 and multiplying it by 10 times 10 to the negative 6. Oh, I guess I don't need a calculator for that. That just moves the decimal 5. So that'll be a negative 4.79, and the coulombs would cancel, and so that would be newtons in the I hat direction. And then this would just move the decimal 5, so it would be a negative 40.57 newtons in the y direction. And just out of my own curiosity, this was what, 47? So 47, didn't stop there. They said that's the components. They went on to say, what is its magnitude and direction? All right, so the magnitude of it.
This is using the just the equations we did in 121, right?
Yeah. So a lot of vector stuff. So take the x component and the y component and square them. This is Pythagoreans Theorem. And 40.57 squared. And then taking the square roots, we get about a 40.85, which they on the answers call it 40.9. And of course, if you're going to do it this way with magnitude, you should also give direction. So if I had a grid here and I drew something that was a negative 4.79 here, and a downward, big downward of 40.57, I would get some angle, and it depends how you want to describe the angle. I'll look at the solutions in a moment, but I'll just get that angle. Let me just call it angle phi. We don't confuse it with our earlier one, theta. But if I was doing then tangent of phi, I would have the opposite, which is 40.57 over 4.79. Grabbing a calculator, then I would go arc or inverse tang of 40.57 and 4.79. And we're looking at about 83.3 degrees. So downward from the negative x-axis is kind of how I describe it. And let me look at the solutions. Oh, that's interesting. Okay, now so the solutions did kind of a math answer where they list the angle all the way from the x-axis. So if we add 180 to this, we're looking at 263.3. So they did the traditional math form, which is okay, but I don't think it's good for a physics class. What they call relative angles is probably better.
Okay. Well, that's much better. I think if I had drawn a better picture.
Oh yeah, I can't overemphasize that. Pictures are golden, man. You got to visualize this thing.
Yeah, because I drew a picture, but then I tried to do something else. But
Okay.
if I had seen that, that would have been much better. Thank you.
My pleasure. All right. Anybody else have a pressing question? I see we're a little after 4:30, but I want to make sure you guys are moving along. So if you have a pressing one, otherwise I'll say shoot me an email and I'll answer it. I still want to make that one video. What's number 60? And I could do some of these other ones, but unless somebody asks again, you guys got the answer. So.
Awesome. Then I don't really have any questions. I was just here today, so then I'm gonna head out. So.
Okay. Good to see you, Hunter, and thank you. And yeah, if you have any questions, send them my way.
Will do. Thanks, Mike. Have a good day.
All right. Take care.
Yeah,
where
I
are you
came in
posting
for,
the?
well, I'm sorry. Continue.
Okay. Where are you posting the recording, by the way? Are you emailing it to us?
I'm gonna try to figure out how to do that on Canvas.
Oh, okay.
Or maybe YouTube if I can't figure it out. But this is good. I was asked to record these help sessions, so by the students at the beginning one, and that wasn't my plan. And so good. Hey, if that helps, more power.
Yeah.
Yeah. So I definitely will post it, and then I'll send out an email letting people know where I post it. And it was pointed out that getting them onto Canvas is probably more useful since it's uniform. And so and I was sharing with others that the way Canvas makes me treat this class as 10 classes really makes it hard to post things that way. But I'm pretty
if
sure.
it's the same class, like there's got to be a way to make it all the same.
You would think
that
so?
Just sounds ridiculous that they wouldn't.
Yeah. Yeah, the reason why is another computer. It's not related to Canvas, but our enrollment system is done on a computer called Banner. And because the labs are at a different time, even though the lectures are, it has to treat it as a separate class.
Huh.
And then that gets once that gets done, it gets sent to me in Canvas as 10 separate classes. And
so you have like the 10 separate classes and then probably a couple for 102 and all that fun stuff.
Yeah, 102 has 3 of them that way. So if I could learn to merge them, that would be so much better. I just need to learn how to do it. I'm sure there's a way, because then I could just treat it like it really is, just 2 classes with a bunch of lab sections.
I guess I have a general question about homework. How do you, I have some things every once in a while written a different color. Like, for example, there's one problem that says prove this is this, and I have it written down. I wrote down what the solutions had written down because I have no idea how they went from one to the other. So I have a literal question mark above the equal sign in the color pink. If I submit it like this, is that going to be fine, or do I have to go through this, come through it, and get rid of all that stuff?
Yeah. Let me explain the homework philosophy to me. Your homework is a learning process. I mean, anybody who thinks that they could read the book and come in and do well on a test is going to be in for a rude awakening. Okay. So the homework is crucial that you do it. But it's the learning process. So that's why when it comes to grading, I'm not going to grade your homework whether it's right or wrong. I'm going to grade, did you try it? Did you work on it? Likewise, then for you write it in whatever form helps you learn and prepares you for the exam. That's really the thought process. So if you do it in color, and if you do it with old-fashioned pencil and paper, and just send me a picture, or if you do it on an iPad and have colored markers, none of that is really relevant to me. It's what works for you because it's part of the learning process. What I'll be looking for then is on your exam, do you know what's going on after these 5 weeks of practicing problems and doing the homework?
All right.
So write it however you want. Use your color and the same thing's going to be said when you take the test. When you take the test, most people will probably do it old-fashioned, pencil and paper, and then just take a picture with their phone and convert it to a PDF and upload it to Canvas. Now I see you have a nice iPad and a screen, so who knows? You may prefer that. In fact, did you guys got the notes from of the video, not just the video lectures, but then there's the video notes. I mean the lecture notes that go with the video lectures. Those were done on an iPad. Those are real notes.
Lecture. Oh, is that the one you said these notes are from a strong student?
Yeah, it's a strong student took notes, and they had a little iPad, and her name's Katie. You probably see it. Says Katie's notes somewhere in there.
Wow.
You sent that to us in an email?
Yeah.
I think it's back on that the one where I described what to do in week 1.
You sent the email out. I received it anyway on August 23rd, 2020 at 2:37 p.m.
Yeah. So that one is, it's got the solutions there and also a link to the solutions and also a link to Katie's notes. They're really good. So as you're watching the video, you can follow along on her notes and even take your own. So that would probably be helpful for anybody listening.
Oh, I definitely might do that. I definitely will do that. Also, I think I forgot. I just read a few different syllabi, and I'm not sure anymore what you're doing for the exams. Did I miss something, or are we?
No, you didn't miss anything on that. I didn't explain anything about the exams, but I'll explain it now. They'll be like you're used to from me, an in-class test, except you'll get it through Canvas. The window will unlock at what would have been your scheduled time of class. And you'll have 2 hours to do the test. And you can do it, like I said, pencil and paper or your iPad. Then I'll give you, I haven't decided if I'm going to give you 15 minutes or 30 minutes. Maybe I'll just give you 30 minutes of technology issues so you can turn it into a PDF and upload it on Canvas. And
okay. Are you proctoring it?
No, this is a very concerning part on all of us faculty. There's no good way to proctor these. It's just students' honesty. But that being said, they are a little different in this way. In a normal setting, I would not have it open book, but I am going to have it open book for just that reason that I can't proctor.
Okay. One final question about the test. I ran into the issue of other people cheating on the exams. The instructor, professor, teacher, whoever noticed people were cheating and made the next exams really hard. So those of us who were cheating, let's just say it was a bit of a shock.
Yeah, that was not fun.
Yeah, I'm not trying to.
Number one, I won't do that because that punishes the honest people, and I don't want to do anything to punish the honest people. I would like to figure out a way to reduce or eliminate the dishonest people, but not at the expense of putting pressure and essentially pushing some of the honest people over the edge and saying, well, you're going to do that to me, then I'm going to be cheating here. And I don't want to push anybody into the abyss. So
into the abyss. Okay. All right.
So I won't be doing that. Yeah.
But since you're making it open book, does that mean it's going to be harder though?
No, I don't want to do that either. So that's not the intent, no. So, although I would say that maybe, because it's open book, it may allow me to do a harder one, because I could say something like this. I could say, look at the equation for the electric field from a ring. Starting there, do a disk, whereas and I could have wrote that out in an exam setting too. So maybe that's not a good example.
Like that integral we're looking at?
Yeah, but then again, in a regular face-to-face setting, what I would do in a regular class, I would say, in the question, I said, you might come across an integral that looks like this. And here's the answer to that if you come across one. That's almost even helpful, because I know many students who do it wrong don't get an integral like the ones I'm giving them a hint for, and they go, oh, I think I'm doing something wrong because I didn't get the one that he's helping me with. And so maybe in that sense, it's a little harder, because I'll just say, if you come across something, an integral that's real hard, feel free to look it up. Don't actually go and do the trig sum. And now that it's open book, you can just go right to Appendix B and look it up.
So that will be a time saver for sure. Trig subs are not my best friend.
Yeah, well, and if I gave you a physics problem that was a trig sub, you end up, it becomes more of a test of your mathematical skills, not your physics skills. And in a face-to-face setting, I'm limited to 2 hours because of the classroom. Now here, I could make it longer and say, okay, do your own trig sub. But again, as you said, probably nobody or very few will actually do the trig sub. They're going to look up the trig sub, So my problems are strategically planned that hopefully test your physics. And then hopefully the homework is requiring you, since you have the time, well, maybe you have the time, but there's no time frame on the homework, you will be able to, judge it two ways. First way, you may be in a hurry today and you go, you know what, I can't really do this trig sub, so I'm going to just get right to the answer and be done with it, and then I'll go over to my job. But then maybe tomorrow you'll sit down and say, I really should know how to do that. So maybe I'll take some time and run through that trig sub. It would be a good review for me, because trig subs are hard, and you did them kind of quickly in 160. So my thinking always is, if you really want to learn math well, you learn it not in your math class, that introduces it to you, but when you actually start to use it. And so that's usually in your physics or your engineering class, is when you learn your math well. And so my thoughts are always that, hey, it's fine if students have forgotten their trig subs. It's kind of expected. But it's also kind of expected, hey, now this is your chance to learn it. You've done it once, now let's do it a second time, and you'll really learn it this time.
Okay.
So are we turning the homework in all at once?
Yeah, I hope this isn't a mistake, but I thought, never I've taught like this before. I thought it might be better to just kind of have you thinking as the test as one big goal, and just say, okay, what I'm going to do is I'm going to learn chapter 23 and then 24 and then 25 and then 26. And instead of having a due date that says you must turn in chapter 23 at the end of the first week, give you a little bit of extra time if you need it, because even though we are online this time and I'm not having a due date, even in a face-to-face setting, when I tell the students it's due at the end of the first week, half the class comes into me and says, this was harder than I thought. I thought I could get it done Sunday night and I couldn't get it done. Can I have more time? And I'm always saying, sure. If you're willing to still work on it, and you should, because if you can't do it, you should keep working on it far better. I won't take any points off. Turn it in on Tuesday, turn it in on Thursday, turn it in on next week. I don't care if it's a week late. I won't even take any points off. Just do it. before the test. So with that philosophy in mind, I thought I would just set it up that way at the beginning.
Yeah, I'm only concerned about like the PDF size and transferring that between them.
It's a really good point. I forgot about that.
Okay, yeah, I did not even think about that.
Maybe you could do each chapter as a PDF and
yeah, you could set up like 4 different assignments, one for 23, 24, 25, 26, and set them all on the same due date.
Yeah.
I could do that, but also couldn't you upload them that way? Couldn't you scan 23 and then upload it and then scan?
Oh, actually, yeah. Can you add multiple You can add.
Yeah, because I think you can do multiple documents.
Okay, you can just have like homework for exam 1 as one link, and then Anthony, you can have like however many documents you want to upload for that one assignment.
Yeah, and then that would be good, because some people, may want to put it in one giant file, and other people might want to break it into each chapter and give me 4 files.
Because I have to scan it on my iPad and then email it to my computer. So, yeah.
What I usually do is I just take a picture of the work, and then from my phone access Google Docs, put them all in a Google Doc, and then make that a PDF, and it's worked out pretty well so far.
Okay, that's good.
All I have to do is send it to me, and it compresses it and turns it into a PDF, and then I give it to you, and that's if I get to use my iPad. But for my math class, it's a Zoom proctored exam, so I have to bring out my pencil, which is covered in dust.
Oh, I see why you're asking. Yeah, I am concerned about people cheating, but I don't know, those Zoom proctoring, I just feel so creepy.
Yeah, and to be honest, I absolutely hate being recorded. So my math class is like, I hate being recorded. I hate having pictures taken of me. This right here is new and I don't like very much. And face-to-face is better than just a blank screen, in my opinion. But anyway, I don't like this whatsoever. I'm getting over it.
When I was taking math in the summer, the way I would like study the formulas and like remember the formulas, but in order to remember the formulas while taking the test, I would have to like draw it in the air. And my math teacher would always look up right when I was like drawing in the air trying to remember the formula. And I'm like, okay, you're just seeing me look weird, but okay.
What class was that? Just curious.
It was Gabe's 200.
Oh, okay.
Yeah, that was a fun one. I took that.
Speaking of 200, I took multivariable calculus over the summer as well with Professor Loftus. Couldn't this electric field stuff be done in a much better way with multivariable calculus? Am I crazy for thinking that?
Yes. No. You're absolutely right. That let me just give you an example. If you watched one of the video answers I gave, which is to find the electric field from a cylinder, and you think about how it was done, we started the problem, and you didn't have to do this for the whole problem, because you could start with a disk for the problem. But remember, the disk came from the ring, and the ring came from a point. Mm-hmm. So if you take a bunch of points and add them up in a ring, then you add a bunch of rings and get a disk. Then you take a bunch of disks and you get a cylinder. You've just done that summation or that integration 3 times. You've just done a triple integral. We just didn't call it a triple integral. Okay. So you're absolutely right that this could be described in a triple integral, maybe with a little more concise manner. But the negative side of that is you don't really want students' physics education to be postponed until they finished all their math education. Okay. So I like to describe it this way, that we're going to kind of sneak around multivariable calculus, and we will never call it a triple integral, but we will call it a single integral 3 times. A point, a bunch of points make a ring, a bunch of rings make a disk, and a bunch of disks make a cylinder, okay? And that will change when you take this class the second time. Of course, it depends on your major, but many people have to take when they transfer to the 4-year university. I'll make it clear. I didn't mean the second time like you were going to fail the first time. What I meant was you need to you'll take it in an advanced level. So this is the level we do now, and you'll see a lot of the things we do will kind of be hampered because our math isn't strong enough. And those are the kind of things you'll do when you transfer to a 4-year university. Your junior year, you'll have to take advanced E&M. In fact, I think Daniel was asking about it in one of the other sessions where we found the equation for the electric field on a ring. And I got to be careful about a ring because it was on the line of symmetry of the ring. We didn't do it off symmetry. That's a little harder problem. But that's a perfect one for multivariable calculus. And so we won't do it. But
are we going to see any, like, I guess, vector fields in this when it comes to like electricity and magnetism together?
I would say you already did, right? All the electric field is a vector field.
I guess a changing vector field, like something that does some nonsense in this class.
Okay, I would say you already had a changing one because here, I'll put it in the camera. If you take as simple as a point right there, point Q.
You're still recording, by the way. I didn't know if you knew that or not.
Oh, yeah. Do I care? Do you want me to stop or?
Oh no, if you're gonna upload it to YouTube, it just might take a while, but keep recording.
Yeah, well, maybe I'll hit